Hello everyone, it's Benny, and in this video, we're going to be continuing working on our shader. Last time, we managed to get a fully generic shader constructor. Right now, all our different shaders are just calling super with a file name. You know, because the shader constructor already does everything no matter what the shader is. It'll build the shader from whatever the file is, it'll find all the attributes in the file and add them. It'll find all the uniforms specified in the file and will add them. And it'll even handle things like structs and whatnot. So we've got a pretty solid shader system going right now. But there's still one more thing we're going to need to change before we can really have a truly generic shader class. One that doesn't need children singletons for every different shader we want. And that's the update uniforms function. We're going to need some way of, we're going to need some way to automatically detect and update all the uniforms in the shader. So, how are we going to do that? It's a ridiculously challenging and impossible task, right? Well, actually no. Because, you see, there's only 3 places that the uniform data can come from. The transform, the material, or the rendering engine. See where I'm going with this? So, here's what we can do. What we can do is we can do something like, in our shaders, prefix data that's not part of the material with something like an X. So this will be X MVP, this will be, I don't know, X ambient intensity, and this will be, I'll rename this to diffuse while I'm at it, because that's going to bother me. But yeah, this can be, something like X underscore diffuse, I don't know. So we've got a prefix for everything that isn't part of the material. And therefore, what do you know? We have a very nice and easy system of telling where the uniform should come from. If it's prefixed with an X, it's going to come from either the transform or the rendering engine. And if it's prefixed with nothing, it's going to come from the material. Now, obviously, you'll probably want something a little bit more advanced than this. So, I'm going to use something like R. So, stuff prefixed with R is going to come from the rendering engine. I'm going to rename this R ambient. And stuff prefixed with T is going to come from the transform. And anything that doesn't have a prefix is going to come from the material. So yeah, that is how I'm going to do automatic, detection of what should set the shader data. So yeah, it's really that easy. Of course, actually, before I break anything, I'm going to go ahead and... Before I break anything, I'm going to go ahead and update my current update uniforms function to have the proper names for things, just so I don't break anything. Just so that I can actually, run it without having an error. Like that. Yeah. Wait a minute. Why would that be causing an error? I forgot to change this to R underscore ambient. Aha! There we go. Now it should be able to run without an error. And there, so now let's go ahead, now that we've actually got it working, and implement our sort of detection system. We're going to look at the prefix, and we're going to, from that, we're going to determine if it should come from the transform, the material, or the rendering engine. But first, we're going to need to know a couple things. First off, we're going to need to know the name of the uniform. Because, that's what we're using to set the uniform. We need to know the name. These things are called, partially because, that's what we're using to update it, like right here, we're looking into the uniforms hash map. And secondly, because we're going to need to know the prefix to determine whether we should update it with data from the transform, the material, or the rendering engine. And here's my thing. We're also going to need to know the type. And you might be wondering, why on earth would we care what the type is. Well, let's say it's part of material. Well, if we look at our material class, we can either get a texture, a vector3, or float. So how can we know which one's which? That is why we need to know the type, so that we can determine, for instance, in material, which one to update, and it can also be useful for the rendering engine and the transform to determine what type of data should be updated from there as well. And yeah, so let's create a few array lists. I'm going to have a private array list. It's going to be an array list of strings. I'm going to call it uniform names. And I'm also going to duplicate that. I'm going to have a string. I'm going to call it uniform types. And in my constructor, of course, I'm going to say these are new array lists of strings. And all I have to do here, see, this is kind of the nice thing about having everything done with the one constructor in the shader class. Because I know all the uniforms will be added with the addAllUniforms function, right? So, all I have to do is wherever I actually add the uniform, in this case it's addUniform with struct check, and in fact, since I think this is only being called, the addUniform function is only being called from here, yeah, it might be a good idea to go ahead and inline this. So here, I'm going to change this. I'm going to say if not add this, then just return. Otherwise, I'm going to inline this whole, this whole thing. There. The reason for that is if I can just call addUniform without the check and whatnot, I won't know about the type, and I won't be able to add them to the array list. So this is just my way of making sure all uniforms are added in a way that, well, that can add the data to those array lists. And while I'm at it, I might as well just rename this to addUniform. Because, if this is what we're going to have to do to add uniforms now, there's no point in saying addUniform with struct check. All the uniforms are going to have the struct check. So there. And now that we've done that, it makes it really easy to determine where to add it. Because I can just say uniform names. If I spell it right, uniform names dot add. I can add the name. And by the same thing, I can say uniform.type, or paste it in the wrong place, but I want to say uniform types.add the uniform type. And there, that makes it very, very easy to know what the name and type is, because they'll be at the exact same index in the array list. And yeah, you could make an array of, you could make this into a struct of just string and string of like name and type, kind of like with GLSL struct, where it's just, name and type. But I don't know. I don't think I need that, so I'm not going to bother. And there. Now, with that, we should be able to, 1, not crash, and 2, be able to iterate through the big, gigantic list of everything. I'm going to do it with a manual for loop, not an enhanced for loop, just because, because it really shouldn't matter too much. Sorry. I'm not talking crazy now. What I'm trying to say is because I'm going to need to access both of the array lists. I'm going to need one string called uniform name, and that's going to equal uniform names get I, and the other string is going to be, well, the type, and that's going to be from uniform types. And there. Now we should be iterating through every single one, and based on the prefix that we have in here, like R or T or none, if it's material, we should be able to determine which one of these three things it should be updated from. So, first off, I'm going to do the check for starting with t underscore. If it starts with t. If it does, then it's going to be part of the transform class. And there's kind of a nice thing with this, because with the transform, there's really only two things that you could possibly want. In fact, I'm going to calculate them at the top here. The first one is the world matrix, and the second is the projection matrix. So, if it starts with t, then there's two cases. Either if uniform name equals, well, t underscore MVP. If it's the MVP matrix, then I can call set uniform with uniform name, and I can set it to the value of the projected matrix. Because that, in fact, I'll rename this to MVP matrix, just because probably more descriptive. But yeah, there, that's the first case. And that should do it. That should do it. Otherwise, if the uniform name is t underscore world, sure, then I can set the uniform based on the uniform name, and I can set that to the world matrix. And there, that should be everything with transform, because transform, there's really not that much you can get from it. I mean, you can get the transformation, or you can get, well, it's not a function of the transform class, but yeah, you can either get the transformation or you can get the MVP, and that's it. But otherwise, we're going to throw an exception. I'm going to say, what type of exception should it be? That's actually a good point. You know, of all the exception types, I think illegal argument exception is probably the most appropriate. Mostly because it's roughly what we're going for here, and because it's an unchecked exception, and I don't want people to have to handle an exception from update uniforms. This is one of the things where it's the programmer's fault. So, yeah. You can write your own exception type for this, but I'm just gonna use illegal argument exception for now. And great! So, actually, let's test it out. Let us, well, yeah, actually, let's comment out those parts, and let's just say super update uniforms with transform material and rendering engine. And, of course, this is in forward ambient, because forward ambient's my guinea pig class. And that should automatically set the MVP to something appropriate. And if not, we've done something wrong. And hey, what do you know? We're not seeing any bizarre visual artifacts, so it's safe to say that this is working. For now. So, now, let's check another uniform name starts with. Specifically, well, the only other one. If uniform name that starts with R, that means it's part of the rendering engine. And now, out of all of these, the rendering engine is really the only one that's going to be a little bit tricky, and that's just for one simple reason. These things, you know, these, the samplers. Because if it comes up across the sampler, then one, it needs to set it to a proper value, but it also needs to go to the material, like we're doing right here, and bind it to that value that it's set to. And that's going to require changing up our rendering engine a little bit. It's also going to require changing up our texture a little bit, which isn't a huge deal, but, you know, it's there. So, in my rendering engine, I'm going to do something kind of like I did in the material. Not exactly, but kind of. Whoa. Okay, I'm going to create a hash map. I should just say that. I'm making a hash map. And it's going to map the names of specific sampler types, like, say, diffuse, to some, well, okay, I guess, integer. And, well, this is I'm gonna call this the sampler map. And of course, in my constructor, I'm gonna initialize this to new, not array list, but a new hash map of string to integer. And that's exactly what this is gonna do. So, for example, I might say, in fact, let me just do it. I might say here, sampler map dot put, I might want to map diffuse to slot 0, which is what we have it at now. If I create something else, like say a normal map, I might want to say, hey, normal is in slot 1. And this makes it a really nice simple. Now, a really nice and simple system for just mapping various material types and things to different sampling slots. And granted, you still have to go in manually and specify which one should go where in the rendering engine, but that's exactly the type of thing the rendering engine should be managing anyways, so I'm completely okay with that. And now all I really think I have to do is, why on earth do I have so many... Okay, first off, let's clean out the rendering engine a little bit. I do not need a set clear color or unbind textures or set textures, or really even a clear screen function. I'm not even sure why I have this. And I'll even get OpenGL version function, because I like that function. It's a cool function. But yeah, don't need to clear the screen. That can be done just manually. There. Oh. Yeah. And now, let's create... Oh, first off in our shader, before I do that, I want to do a check. And that's if uniform type is, well, whether this is a sampler 2D. Because if it is, that's exactly the type of place where the rendering engine is going to come in. So, yeah. So if it is a sampler 2D, then 1, I'm going to want to bind it. So, actually, while I'm at it, I might just say string unprefixed uniform name, which equals uniform name. It's going to be a substring starting at, well, index 2, right? Because, well, that's length 1, that's 2. So yeah, I think that's it. And bind it like that. There. So I'm going to get the texture of the unprefixed name and bind it, but secondly, I'm going to need an int. And that's going to call it sampler slot. And that's what I'm going to get from this hash map I made in the rendering engine. So, I'm going to say get sampler slot with some name. It's going to be our new function. So in fact, let me just copy this. Public int get sampler slot, taking in some string, sampler name, and whoop. Oh, well, I guess I don't need to copy anymore, but yeah. It's just going to return sampler map get from sampler name. There, just return whatever's there. And I'm also going to change my bind function here in a moment, actually, right now. But yeah, it's going to take in a sampler slot, so we can choose which slot to bind it in. So yeah. And finally, I'm going to need to do set uniform with uniform name to the sampler slot. Oh, wait, it would be set uniform because it's integer. There. And that should be almost all there is to it, except for changing this, which is easy enough. I can just say taking in int sampler slot. And this is going to use GL active. I could have sworn it was called GL active, or active texture, you know? Isn't that what it's named? Active texture for, you know, for GL texture 2D to something like GL texture 0, you know, something like this, or GL texture could have sworn it was something like this. Huh. One moment. And yeah, I was mostly right. It's GL active texture with GL texture 0. I just hadn't imported the static language object GL13.star, that thing. And for some reason, IntelliJ didn't pick up on that. So, But yeah. So I'm going to start at texture 0, and I'm just going to add sampler slot. And, yeah, technically you should probably do something like assert that add sampler slot is both greater than or equal to 0, and sampler slot is less than or equal to 31. And in fact, I will do that for right now. But really, since the rendering engine is managing it, it shouldn't be a big deal. And while I'm at it, just so I don't break the code immediately, I'm going to just say bind, add a bind function which just passes in 0, and there. And this also means I should be able to get rid of that, and build, and now it should pick up on that. It should be able to, well, you know, get, what's it called? Should be able to automatically, yeah, bind the proper ambient texture. So there, it's found it, it's bound it, and it's all working out beautifully. So great. So that's the tricky part of setting up the rendering engine. So otherwise, if it's not of a sampler 2D, then here's what I can do. I can do, well, something kind of like I'm doing in Material, where you know, I'm going to try something. I'm going to do some I'm going to improvise some code. So this may go horribly, horribly wrong, but yeah, I want to do something kind of like I'm doing in Material. This is a part where I'm going to do kind of like Material. We're going to have a hash map with string to some type. Oh, right, that's not going to work. Never mind. Yeah. It's going to have some like float and vector hash map, just like the Material. In fact, I'm going to copy the code from there. It's going to have add vector and add float, just like the, oh, what's it called? Just like Material has. Yeah. Except this is all going to be private stuff. I'm not going to expose adding stuff to the rendering engine, because that's just asking for trouble. So yeah. And in Material, I'm going to have the get and the get float, just like with Material. And yeah, there's probably some common sort of interface I can put this. In fact, I'm probably going to do that in a moment, but yeah, for now, I'm just going to leave this as it is. Although, yeah, in a moment, I am going to make a common sort of interface for it. And yeah, so else if uniform.type or uniformType.equals, if it's a vec3, then I'm going to say set uniform with uniform name and with RenderingEngine dot get vector3f with uniform name dot substring 2, because you know, don't want to specify all the rendering engine parameters with the R prefix. That's just for shader conventions. And finally, I'm going to also do float. You can support more types later if you want. I'm just going to support these two for now, because I think those are really the big types. So, except this one's going to set uniform F with get float with that. And I forgot one more closing brace. Great. So really, we should now have the rendering engine part of things fully supported, and better yet, we should be able to comment this out, and that will require us to rearrange the rendering engine a bit to use our new stuff, but hey, that's okay. So I'm going to add a float, I'm going to call it ambient, or add a vector 3f called ambient, and it is not going to do that. Thank you very much, auto-formatting thing. But yeah, it's going It's not going to do that. It's going to... In fact, wait, why do I need that? I have... Yeah, I don't even need these functions in here. Never mind. What am I doing? Okay, I'm going to say float hashmap.put with the name ambient, and the value is going to be whatever my ambient light is right now, like this. Yeah, there. Hey, to a new vector 3 of that. Yeah. And... Oh, wait. Wrong hash map. The vec is going to be in the vector hash map. There. Now that shouldn't break anything. And I should be able to get rid of the getAmbientLight function, because it's not being used there anymore. And I should be able to... wherever it is. Shader. There it is. Oh, I already did that. Never mind. So let's build and run, and let's see where this breaks, where it doesn't, or if everything just so happens, just by chance, happens to work. No, it doesn't. Okay. Put ambient. Ah, because I never initialize it. Okay. In fact, let's just go ahead and do things the right way, and make things like add vector 3f and add float sort of, well, as a common abstract class sort of thing. So I'm going to put it in resource management because it's sort of a resource thing, I think. If not, I can move it somewhere more appropriate later. But yeah, I'm going to call it sort of a... not named variables, I don't know. I'm going to call it mapped values. And this is going to have sort of the same thing we're doing in material, with the vector 3f and the... yeah, those things. And the get and set for them. So there's going to be public void things that get it, and public type things that... or wait, you know, getters and addition things, yeah. Getters and setters, basically. And in the constructor, which I'm going to put... yeah, I'll put it right here. Public mapped values. I'm going to initialize them, just like I did in material. That also has the side effect of greatly simplifying our material class. But yeah. So, I'm going to make this an abstract class, so you can't actually make instances of it. So, and, yeah. Material is going to extend mapped values. And in the constructor, I should be able to just call super with nothing. And there. So with that, it should be that simple. RenderingEngine, I should be able to do the same thing. It's going to extend map values. And here, I'm just going to say super and nothing. And I should be able to just get rid of that stuff now. So, yeah, and change this to add... oh, right. Import the class. And then change this to add vector 3f. Yeah. And... get rid of this. And there. Makes it that much easier, and nice code reuse. So now let's see if it's still breaking down and crashing and not working and all that stuff. No! Great! It's all working just fine now. We've got ambient light working, and with that, you know what that means? Our ambient shader, at least, is being handled fully generically, completely by, well, our default update uniforms function. So, and really that, I can go ahead and finish this off now because there's not that much more to it. But yeah, I'm going to do the same sort of check here. Going to check for type. Yeah, uniform type. Except I'm going to get it from the material instead. And I'm not going to need a substring or anything because, well, they're just as they are. If uniform or material stuff doesn't have a prefix. And that should put all the pieces in place to start breaking down some of these classes, making fully generic update things. But I think this video's gone on long enough, so thank you. Hope you enjoyed, hope you learned, and I'll see you in the next video, where we'll extend our shader system, our little update uniforms thing, to work for our lighting things and structures and whatnot. So thank you, hope you enjoyed, hope you learned, see you then.